Hey everyone, welcome back to our Java programming series. Today we're diving deep into one of the most fundamental concepts about Java operators. Whether you're a beginner just starting your Java journey or someone looking to refresh your knowledge, this video will cover everything you need to know about Java operators. First, let's understand what operators are. Simply put, operators are special symbols that tell Java to perform specific operations on values or variables. Think of them as the tools that let you combine, compare, and manipulate data in your programs. Java provides a rich set of operators that we can categorize into several types. Some of these operators are arithmetic operators, mathematical functions, relational and Boolean operators, bitwise operators, and several others we'll explore today. Let's begin with arithmetic operators. These are the bread and butter of mathematical operations in Java. The four basic arithmetic operators in Java are addition, subtraction, multiplication, and division. Let me show you these in action. Now here's something really important about the division operator. When you divide two integers, Java performs integer division, which means it discards the decimal part. Notice how 10 divided by 3 gives us 3, not 3.33. That's integer division for you. There's one more arithmetic operator, the modulus operator, represented by the percent sign. This gives you the remainder of a division operation. So 15 divided by 2 is 7 with a remainder of 1. The modulus operator gives us that remainder. When you divide integers by 0, Java throws an arithmetic exception. But with floating point numbers, you get special values like infinity or not a number. Now let's explore Java's math class, which is packed with useful mathematical functions and constants. Need to calculate a square root? Java got you covered with Math.sqrt method. Unlike some languages, Java doesn't have a power operator. Instead, we use Math.pow method call. Here's a really cool method that solves a common problem. You know how the modulus operator can give negative results with negative numbers? Well, Math.floorMod always gives you a non-negative result. Let's think about this with a pizza example. Imagine you have a pizza cut into 8 slices, numbered 0 through 7. You're at slice 6 and someone tells you to move backwards by 10 slices. Where do you end up? Negative slice, that's confusing. You'd have to write extra code to fix it. But with FloorMod, it's much simpler and always gives you the right answer. So if you start at slice 6 and move back 10 slices, you end up at slice 4, which is exactly what FloorMod gives you without any extra work. The math class also provides all the trigonometric functions you'd expect. For exponential and logarithmic operations, we use methods math.exp, math.log, math.log10 of math class. Java provides two important mathematical constants, math.pi and math.e. Now let's talk about something that trips up many Java developers, numeric type conversions. Java can automatically convert between numeric types, but only when there's no risk of losing information. These are called widening conversions. But some conversions can lose precision. When you perform operations with different numeric types, Java follows specific rules. If either operand is double, both become double. Otherwise, if either is float, both become float. Otherwise, if either is long, both become long. Otherwise, both become int. Sometimes you need to force a conversion, even if it might lose information. That's where casting comes in. The syntax is simple. Put the target type in parentheses before the value. If you want to round to the nearest integer instead of just truncating, we can use Math.round method. Notice we still need the cast to int because Math.round method returns a long, and long to int requires explicit casting. Java provides convenient shortcuts for combining assignment with arithmetic operations. Instead of writing x equals x plus 4, you can write x plus equals 4. This works with all arithmetic operators. Two of the most commonly used operators in programming are increment and decrement. These operators add or subtract one from a variable. These operators can only be used with variables, not with literal values, so 4++ is not valid Java code. Here's where it gets interesting. There are two forms of these operators, prefix and postfix. The prefix form does the increment first, while the postfix form uses the old value first, then increments. Now let's explore relational and Boolean operators that help us compare values and make decisions. To test if two values are equal, use the double equals sign. For inequality, use the exclamation point followed by equals. The usual comparison operators work as expected. For combining Boolean expressions, Java provides logical operators, logical AND, logical OR, and logical NOT. Here's a powerful feature. Java uses short-circuit evaluation for logical and logical OR. In this example, since x is 0, the first condition is false. Java doesn't even evaluate the second part, so we don't get a division by 0 error. Java also has a ternary operator for concise conditional expressions. This reads as, if is less than y, then smaller equals x, otherwise smaller equals y. Now we're getting into more advanced territory with bitwise operators. These work directly with the binary representation of numbers. The bitwise operators are bitwise AND, bitwise OR, bitwise XOR, bitwise NOT. Bitwise AND will compare each bit position. The result is 1 only when both bits are 1, so the result will be 1000 in binary, which is numeric 8. For bitwise XOR, the result is 1 when bits are different, so the result will be 110, which is 6. Bitwise NOT will flip every bit, 0 becomes 1, 1 becomes 0. Finally, let's talk about operator precedence, the order in which operations are performed. Just like in mathematics, Java has rules about which operations happen first. Multiplication has higher precedence than addition, so 3 multiplied by 4 is calculated first. When operators have the same precedence, associativity determines the order. Most operators are left to right, associative. Assignment operators are right to left, associative. Here's a common example with logical operators. When in doubt, use parentheses to make your intentions clear. Wow, we've covered a lot of ground today. Let's quickly recap what we learned. Arithmetic operators for basic math operations, the math class for advanced mathematical functions, type conversions and casting, assignment shortcuts and increment decrement operators, relational and Boolean operators for comparisons, bitwise operators for low-level operations, operator precedence and associativity. Understanding operators is crucial for any Java programmer. They're the building blocks that let you manipulate data and create complex logic in your programs. If this video helped you understand Java operators better, please give it a thumbs up and subscribe for more Java tutorials. Drop a comment below if you have any questions or topics you'd like me to cover next. Thanks for watching, and I'll see you in the next video. Keep coding.